In this video, we're going to be taking a look at a circular motion funnel problem where we have a small 0.1 kilogram object that is going around a circle with a radius of 30 centimeters at that particular part of the funnel. And what we're going to do is solve for the velocity as it is completing the circular path at that portion of the funnel. So we have one angle to work with over here. We're going to go ahead and draw our forces. We have the force of gravity straight down, which is also known as mg, mass times 9.8. And then we also have the normal force from the funnel pushing up perpendicular to that surface. Now, the key to this problem is to break the normal force into its components. So we have a horizontal component going this way, and then we also have a vertical component going this way. This horizontal component over here is actually going to be our centripetal force, which is mv squared over r. And then our vertical force over here is going to be equal and opposite of that Fg, because there are the only two vertical forces. Therefore, this vertical component of the normal force is going to be equal to mg. Now, if our 30-degree angle is right over here, and it looks like we have a 90-degree angle right here, and also a 90-degree angle right here, then we have a 60-degree angle as this part of the triangle, and then that would mean that this angle right here is the complement to that 60. So that 30 degrees actually translates right up into our triangle right over there. Now, we're going to use a little bit of trig to figure this out. We have two parts of our triangle we're going to use, which is the opposite end of the 30 degrees and then the adjacent end of the 30 degrees. So that means we're going to want to use tangent. So the tangent of 30 degrees equals the opposite end, which is mg, over the adjacent end, which is the Fc, the centripetal force, which is mv squared over r. Now what we can do is do a little bit of rearranging because our goal is to solve for the velocity. The m's actually drop out, so we're not going to need our mass of 0.1 kilograms. The r, because it's in the denominator of this fraction that's in the denominator, when you divide by the reciprocal, or excuse me, when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So the r flips up top. So then we're going to have the tangent of 30 equals gr over v squared. And then we're going to end up cross multiplying these two numbers. Okay, so let's go ahead and plug in our number values and see what we get for this velocity.
Avant, tu voyais que de la merde. Maintenant, au moins, tu vois plus rien.
All right, so we plugged in our number values. We have the g value of 9.8. Our radius was 30 centimeters, is 30 centimeters. So when you divide that by 100, that comes up to 0.30 meters. And then we cross multiplied the v squared and the tangent of 30. So we have tangent of 30 in the denominator. And then we got v equal to the square root of 5.09 once we square rooted both sides. And then we end up with a velocity of 2.26 meters per second. So when solving a funnel problem like this, assuming that it is frictionless, which will add a whole nother component of difficulty and complexity to the problem, we can just take a look at the normal force and the force of gravity and break up the two components of our normal force. And like I said, the key to solving this problem is recognizing that our force that is pointing towards the center of our circular path is our horizontal component, mv squared over r, and then our vertical component is mg because it is equal and opposite of this mg. And then from there, we can just do a little bit of trig, set up our values over here, which makes your m drop out, and then from there, it's just a little bit of algebra to solve for your velocity. So I hope that was helpful in helping you solve a funnel circular motion problem. Thank you for watching and listening.